We begin in a void. From the outside, it appears that there is nothing. This desolate place between stars, while seemingly empty, is actually just full enough to create miracles. So perhaps it would be wise to take a step back. If this isn't a pure void, then what is there to accompany us on our journey? This single dust speck, alone in the vastness of space, searches for a friend. At first, it sits still, unable to change course. Then, as the river of time flows, gravity begins to overtake its destiny, and collisions begin. This gathering of dust, called together by gravity, is the start of a chain reaction of sorts. What follows is a place of higher gravitational strength, causing more dust to coalesce. Conservation of angular momentum, another important player in the game of stellar life, increases the speed of the gas cloud's rotation as it collapses due to gravity. A protostar is formed. At this point, the heat is being generated by gravitational collapse and not nuclear. When the shift occurs, the protostar has fully become a star. An adult star is made up of 6 parts: the core, the radiation zone, the convection zone, the photosphere, the chromosphere, and the corona. Each part has its own unique function, though the most important thing is that the star is fusing and staying in balance. In hydrostatic balance, neither fusion nor gravity overcomes the other, keeping the star at roughly the same size and shape. As it runs out of fuel in the form of hydrogen, the star expands into a red giant. Then it performs hydrogen shell fusion and helium core fusion in equilibrium until it approaches double shell fusion, after which the star will shed its outside layer and leave behind a white dwarf. Of course, the fate of a supergiant is much different and far more volatile. Instead of leaving behind a white dwarf in a rather calm manner, the stellar engine explodes and, depending on the mass, can either leave behind a dense neutron star or a terrifying black hole. Other than their different compositions, with higher mass stars having heavier elements, there is another important difference between these two types of stars. The smaller a star is, the longer it lives, to the point that high-mass stars can die in only a couple million years, whereas smaller red stars can live tens of billions. Formed with a mix of gravity and luck, stars are, in the age of our universe, modern creators that have given us our home. They make and make, but behind this creation is tragedy. Only from their deaths can we be birthed. For them to live, we cannot. Even in space, Darwinism hasn't lost its power, though in the void, only the small survive.